Welcome to Ask and Learn.
In this exercise, we're going to be talking about circular motion and frictional force. So I'm going to review these topics before starting to solve the exercise. Regarding circular motion, we know that the centripetal acceleration that's associated with the circular motion is equal to v squared over r. And this acceleration regards the change in direction of the velocity of the particle. R is the radius of the trajectory and v is the speed of the particle. Also, we have the tangential acceleration that is tangential to the trajectory and is equal to the derivative of the speed of the particle relative to time. So it pertains the change in magnitude of the velocity. About friction force, we need to know that there are two types of friction force, static and kinetic. For the static friction force, it can vary from 0 to a maximum value that is equal to the coefficient of static friction, μs, times the normal force that the surface exerts on the object. And for the static friction, the object must be still. If there's a force that acts on the same direction of the friction force and is greater than the static friction, the maximum static friction force, then the object starts to move. And that's what we need to know in order to solve the exercise. So what we have is a girl that is on the edge of a merry-go-round. The girl has a mass of 25 kilograms, and the merry-go-round has a radius of 1.5 meters. And we also know that the coefficient of static friction between the girl and the merry-go-round is 0.3. And our goal is to find what is the maximum speed of the girl such that she doesn't slip on the merry-go-round. Well, what we need to do first is to draw a free body diagram on the girl. So this is the girl. There's the only forces that act on the girl are the gravitational force that acts downwards. We also have, besides the gravitational force, which is mg, we also have the normal force that the merry-go-round exerts on the girl. And we have the friction force that is perpendicular to the normal and the gravitational force. Okay, this is the frictional force, and is the only force that points in the centripetal direction, in the radial direction. Since the girl is not moving in the vertical, then the normal force must be equal to the gravitational force, so N is equal to mg, and the frictional force must be equal to m times the centripetal acceleration. Notice that the exercise tells us that the merry-go-round increases its speed slowly enough so that we can disregard the tangential acceleration. So the friction force, is completely in the centripetal direction and is equal to m times the centripetal acceleration, which is v squared over r. Now, if we want to find the maximum value of v, then we should use the maximum value of the friction force. And the maximum value of the friction force is μs times mg. So I have μs mg is equal to mv squared over r. So v is the square root of μs times g times r. μs is equal to 0.3. G is 9.8 meters per second squared, while r is 1.5 meters. So v is equal to 2.1 meters per second. This is the speed, the maximum speed of the girl in the merry-go-round before she starts to slip, which concludes our exercise.